Hi, and welcome to this video lesson on solving exponential equations using logarithms. For those who don't know what a logarithm is, here's the definition of a logarithm algebraically. That is, a to the c power equals b is equivalent to saying log base a of b equals c. So notice that a is the base of this exponential equation, and it's considered the base of the logarithm here also. So in other words, the base of the logarithm is raised to this c is actually the exponent. A to the c power equals b. So something as simple as if we have the log base 2 of something is equal to, let's say, 3. This means 2 is the base, 3 would be the exponent, so this would be 2 to the third power would have to be equal to 8. So this means 2 to the third power is equal to 8. So a is again the base of the power, and also it's the base of the logarithm. So this is read log base 2 of 8 equals 3. So this means that we can rewrite any simplified exponential equation of this form, a to the c power equals b, in log form, log base a of b equals c. And that comes in handy when we solve equations like this, 5 to the x power equals 100. Notice that 5 is the base, just like a is the base. X is the exponent, similar to how c is the exponent here. And then 100, that's the power. 5 to the x power is 5 to the x is equal to 100. So in log form, this would be log, take a moment, the base here, it's a, so the base here is 5. And notice that x is the exponent in this expression, and so it's going to be equal to, x will go here, and then the 100 is what's called the argument of the logarithm. So it's the log base 5 of 100 is equal to x. So actually, we have our solution. It's just that simple. The x is equal to the log base 5 of 100. Now that expression, log base 5 of 100, I'm going to rewrite that. That expression is hard to really interpret directly, and sometimes I'll use cursive, lowercase. So log base 5 of 100, what is that equal to? Well, we could have come back here to the original equation, and 5 to what power is equal to 100, you might ask? Well, 5 to the second power is equal to 25, and 5 to the third power is equal to 125, right? So that means that x, if it was a 2, that would be too small, 25. And if it was x was a 3, that would be bigger than 100, so that would be 125. So we do know that x is between 2 and 3. So we could start guessing. I mean, that might give us as much information as this. So for all we know, what is log base 5 of 100 equal to? Well, it's something between 2 and 3. Well, some calculators are capable of just putting log base 5 of 100, and that's all nice. You could do that on your calculator and approximate it. But many calculators don't do that. And so to rewrite that, the log base 5 of 100, that can be written as the log of 100, this is called the common log, which we'll talk about, over the log of 5. So I'll just show you on a calculator that we don't have log base 5 of 100 on most calculators. So if we take a look at this calculator, let's clear that. You notice this has a log key right here, log. That's called the common log. Notice it doesn't have a base on it. It's assumed to be 10. So this is called log base 10, or just log of something. And this ln is, that looks like an in, but that's an ln, which stands for the natural log. So that's a different base, a base of e. But anyway, log, if we push the log button and we get the log of 100, your calculator can do that quite easily. Notice it prompted a parenthesis, so I'm going to have to close that off. And then divide by, and then the log of, and again it prompts a parenthesis, so I'll hit 5 and then close the parenthesis there. And now that's the log of 100 divided by the log of 5, and it is equal to Here we are, 2.861,35312. Now, let's say that the question said they wanted an approximation, and they only wanted it rounded to the nearest thousandth. So then we go back and say, okay, that means that x is approximately 2.861. If you remember, let's look at that real quickly again. It was 1 followed by a 3. So there's tenths, hundredths, thousandths. The 3 is not enough to bump the 1 up. So we'll just leave it as 2.861. And that is our solution. Okay, that's hope you enjoyed this lesson and learned something from it. I'll be back with a little more challenging problem.